Hey everyone, myself Bhavya Goyal, a student at IIT Gandhinagar. I welcome you at CodeChef and let's have a look at this question. Hello everyone. Today we'll be discussing this question, Equalize juice. So in this question, chef is hosting a party. In preparation, he has laid out n glasses of juice on a table in a line, and the ith glass from the left initially has A of I juice, units of juice. And for aesthetic purposes, chef wants that each of the glasses should have equal amount of juices. So for that, he can do the following operation. That is, so let's say we have some n juices. So A1, A2, A3, A of n represents the amount of juices each glass has. So in one operation, what he can do is he can choose any of these glass. Let's say choose this glass. He can split the amount of juice it has to its neighboring ones. So let's say it had seven. So we could, let's say, give 1 unit of juice to this and 6 unit of juice to this. Or he could also give like 3 unit of juice to this and 2 units of juice to this glass. And this glass itself will be removed from my array. And the total count of the number of glasses I have will reduce by 1. So this is what we are allowed to do. And we need to tell the minimum number of operations that chef needs to do such that all the remaining glasses have an equal amount of juices. So this is pretty much the question. Let's see the constraints one. So we have t in between 1 and 1000, n in between 1 and 5000, and a of I in between 1 and 1 billion. And we're also given that sum of n does not exceed 5000. So clearly from the constraints, we can have a time complexity of at least n square, right? So we can just keep that in mind for the solution. Now let's see the sample inputs once. And the first sample input, we're given 1, 6, and 2. So we could remove 5 units from this. So what we could do is we can send 3 units of juice to this glass, 2 units of juice to this glass, and 1 unit would be just wasted, and we're allowed to do that. And in the end, we'll have 2 glasses with 4 units of juice each, right? In the second input, we just don't need to do anything. Already all the glasses have equal juice, so the answer is 0. The third input, we have 4, 3, 1, 1, and 2. So what we could do is we can just try to make the total amount of juice as 4, or we can just try to make the total juice as 3. So we'll remove this glass and not do anything. We have 3, 1, 1, 2. We can remove this glass and send this to here. So 3, 1, 3. And we can remove this glass and not distribute the juice to anything. So we'll be having 3, 3. So we did a total of 3 operations, which is the answer. And you can just find that it is the most optimal way to do it as well. So now let's move to the solution. So to start with, can we reduce the amount of juice in any of the A of I's? So let's say this glass have a juice equal to 5 units. Can I make it less than 5? So if I do an operation on this glass will be removed altogether, right? So that is not a way of reducing the amount of juice it has. And if I do an operation on either of the adjacent ones, the amount of juice can only increase, right? So this is a very general observation of the question, that is, you can never reduce the amount of juice in any of the glasses. You can only increase it. Now, what does minimizing the number of operation mean? This is just I have written for the sake of writing, so it's very obvious. So we just need to maximize the number of glasses that are left in the end, right? Because in one operation, we are removing a glass and we want to remove minimum number of glasses possible. So we just want that in the end, we are left with maximum number of glasses possible, right? So to start with, let us assume that we know that all of my final glasses will have a juice equal to some number x, right? So for example, let's consider x equal to 5, and these are the glasses I already have. Now I want to remove minimum number of glasses such that all of the elements, all of the remaining glasses have some the amount of juice left equal to 5, right? So to start with, let's try to think of some greedy way of doing it. So, okay, initially we are on 3. We know that we cannot make it 5 as of now, right? So we cannot make the amount of juice as 5, but we do not want to remove it already, right? Also before that, notice that this glass has to be removed. because the total sum has to be 5. So there's no way that I can keep this in my list of glasses because all the glasses must have equal weight and there is no way of reducing the amount of juice in this glass, right? Similarly for this and this, right? Now over here, this 3 cannot at all be removed, right? I mean, this cannot be filled with 5. So, but we do not want to remove it already, right? So it will have 3 amount of juice only. And we'll try that. We'll bring in some more juice from our future and put that inside this glass to make it 5. The next glass is 20. So what we'll do is take in 2 units of juice from this and put it inside this 3. So we'll have 5 inside this and 18 amount of juice is still left, which I can propagate to my further glasses in the future, right? And this had to be removed. Why? Because 20 is bigger than this 5, right? So I have 18 amount of juice, nothing is there over here, and I can still add it to some of my glasses. Now this is 1 unit of juice. So can I make it 5? Obviously I can, right? So this became 5 and I'm left with 13 more units of juice. But can I still store it and propagate it to my further glasses? So to do that, I'll have to remove this glass so that I can send it to the future, to the future glasses. But if I do that, then my this glass would be removed, which is a valid, really valid glass, right? And we want to remove minimum number of glasses, so it's better to not remove this glass. And the amount of juice which we can send to the future is 0, right? Now this has initially 1 amount of juice, so we can't do anything. Now, okay, this also has 1 amount of juice, but we'll try to fill in this glass first, right? So this one is extra. Now we also have 8 more units of juice, so we total have now 9 units of juice, and now we can fill up this glass, right? So we can send the juice from this to this and from this to this, right? So once sending, I'll still be left with, so in total I have 10 units of juice, 1 plus 1 plus 8, right? And I just need 5 units. So I can send all of my 5 units to this and I'll still be left with 5 units. So just to explain it once again, what we did is we broke this up. We sent 4 over here and we still have 5 which we can send to the future. And we had this 5, we sent this over here and or you could say that we just send this 1 over here first. So this is 9. And now we sent 4 over here and 4 over here and 5 can still be sent in the future. Right. So I still have 5 amount of juice left to send in the future. And this 1 and 8, both have to be removed. Now I have this 1 over here. So, and I still have 5 units of juice left. So I can fill it up already. So it will become 5 units of juice and I have 1 unit left. But again, can I still propagate it further? No. Why? Because to send it further, I need to remove this glass, which I do not want, right? So, okay, now I have left 0 amount of juice because I cannot send it further. Now this 2 cannot be filled. So we'll keep it 2 for now. And we'll bring this 3 from the future. So this will become 0. So I have 0 amount of juice left. It says 5 and this had to be removed. Now this 8 is there. So it's better that I keep 5 as the juice and just waste 3 units of juice. So in total, we removed 4 number of glasses, which is the most optimal for x equal to 5. Right. Now, this is a general idea of some greedy approach we can do to get like to get the minimum number of glasses we need to remove for some x. But now, what is a generalized way of this greedy, right? So I'll just generalize it with a few terms to see how we can actually implement this greedy. And as of now, I hope the intuition about the greedy is fine, like how or why it's really working. So let's start it with this. So this small will represent that have you already found some index which is less than or equal to x? Because if let's say I had 30 over here, I could not use this 30. This 30 was useless because I have to remove this, right? So all of these 30 units of juice would be transferred to my next future ones, right? So we'll start with this 3. Initially, we'll have these as -1, 0, and 0. Now, okay, we are on this 3. We have found the index which is less than 5, less than or equal to 5. So we'll mark it as 1. Now the left index, so left stores how much juice I had before this small index, which I can put into my small index and hopefully amount of juice matches this x, and we get how many minimum number of glasses we need to remove. And this right will store the amount of juice I got after getting this small. So these would be much more clear once we just try them through it. So initially we have small equal to 1. Did we have any left? No. Do we have anything to the right already stored in the units? No, right? So, okay, we'll just continue. So from this, we'll continue to this. Okay. Now we got this 20 units of juice. So which is to the right of our small index, right? So we'll increase the right by 20. Now now we'll check. Can we fill up this small index? If it is -1, then we just need to continue because we still need to find some small index. But if it is not -1, then we'll see that can we fill up this small index with juice equal to x. Can we do that? So, okay, we have 20 units here and 3 unit is already there in my glass one. So in total, I have 23 units. And how much I need? 5. So if I fill it up with this, I'll be left with 18 units. So I'll reset my small index to -1 because I could fill up that previous glass. My right would be reset to 0 because I don't have any small index. So my right is 0. And my left would be reset to 18. Why? Because I can send this 18 units of juice to my next whatever glass I get. Right. So what we basically did it is we sent 2 units here and 18 units we kept if in case we need to send it to the future, right? So this got filled with 5. This was nothing. So we can keep an answer which will be 1 because we could store 1 glass, right? Now we'll continue. We got this 1. So this 1 is less than 5. So we'll update our small with 3 because we got some index with the amount of juice less than x. Now we already had, now we'll check. Can we fill up this glass or not? Can we? Yes, we can. Why? Because 1 plus we have this left amount of juice already. So this will be reset to -1. This will have 5 units of juice. Now left, what will left become? So do we have anything in the right? No, right? And as we discussed above, we cannot send this to the future now, right? So this has to be reset to 0, right? Now similarly, over here we have 1. We again got a juice with 1 unit. Now do we have anything to its left? No, it was 0. Do we have anything to its right? It was 0. Can we fill up this glass? No, we cannot. So we'll continue. We came here. So okay, so our right got increased by 1 because there is some juice which I can get from the right to this small index. Now, can I fill up my glass? No, I cannot. So we'll continue. We got to this 8. So my right became 9. Now, can I fill up this small index? Yes, I can. So this has to be removed. This also has to be removed because nothing would be done. And this will become 5 because we can fill it up. And after filling it up with 5, how much juice is left? That would be our new left, right? Because this is -1. Now we can say that we have some amount of juice left which you can send to our future, right? So this will become 0 and our left will become 9 plus 1 minus 5. That is the amount of juice we had over here plus the amount of juice we had in the right minus x. So that is the amount of juice we can send to our future, right? So we have left equal to 5. Now we'll go in this index. Is this a small index? Yes. So make it a small. So it will be 7. Can I fill this index? Yes, I can. So we'll just simply fill it with 5. Now, am I left with anything? No. So it will have to be 0, right? And this will just keep on iterating this greedily and we'll get the minimum number of glasses we need to remove. And I really hope the intuition on why it's working is clear because what we're trying to do is we're trying to remove a glass if and only if it is absolutely necessary, right? So yeah, this is pretty much the generalized way of greedy. But now we don't know what this x is, right? So how many total possible values of this x could exist? So it turns out that the maximum number of values of x are n. Why? And what are those n values? They're nothing but a1, a2, a3, dot, 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 a of n. So we could try all the possible values of x as a possible candidate. We get what are the minimum number of glasses I need to remove for each one of them. And in the end, we can print that n minus the minimum number of glasses or whatever. And that is pretty much the whole solution. Now, why are these values enough? So notice that if we are using any value which is not already a part of our array, that means we created that array, created that value, right? So if x does not belong to, or it does not, so it does not belong to this set of numbers, that means this x was created by splitting sum of the a of I into two adjacent ones. And because we are allowed to waste some juice, we could already get it using either of those three numbers, right? So instead of increasing that, we could get that exact same amount of operations using these only. And that would be more optimal because we are reducing one less number of this glass, right? So this is pretty much the whole solution. The time complexity would be O of n square because for each of these candidates, we are running this O of n greedy approach, and that's it. Now let us see the code in C++ first. So we'll begin by taking the input of all the test cases. We'll run a loop for each test case. Now we'll initialize our answer as 0 and we'll call this best of x function, which will tell us that what is the minimum number of glasses I need to remove for this particular value of x. And we'll take the max over all of them. Now this is a lambda function. You can look over the web on how lambda functions work in C++. So we'll define this left, which will store the left sum as we discussed, and right will store the right sum. Now we'll iterate on each of the element. And if my small is minus 1, that means my small is not defined. So we'll check if my current element is less than or equal to x. If it is, that means we got a possible candidate for the small value. So we'll set the small as I. Otherwise, we'll say that, okay, this element is bigger than our small. So let's just keep it inside our left to give it to some future possible candidate. Otherwise, if it is not minus 1, that means we already have a smaller candidate, but we're still trying to gather more units of juice to give it to that small index. So we'll increase the right with a of I, a of I. Now, if our small is equal to minus 1, we'll continue because we don't have any small index yet. So it's useless to check if we can fill in that small index or not. Or if our small is not minus 1, we'll check can we fill up that small index. So if a of small plus the amount of juice in the left plus the amount of juice I can bring from the right is greater than or equal to x, we'll increase our answer and we'll just update our left and the right values. Right would be 0, we'll update our left this way, and our new small index will become minus 1. And in the end, we'll return answer, and this is pretty much the whole solution in C++. Now let us see the solution in Python. So yeah, this is the whole solution in Python. So this is for fast input output. So it will take the input faster than the normal input. We'll run a loop for each of the test case. We'll take in the input of n and a. We have created a variable answer which is 0 initially, and this best of x will return us the minimum number of glasses we need to remove such that the sum of the amount of juice in each glass is equal to x. And in the end, we'll print n minus answer. Okay, just a correction. I think this best of x is returning us the maximum amount of juices we'll be left with instead of returning the minimum amount of glasses we need. So it will return us the maximum amount of glasses we can still have in the end instead of returning the minimum glasses. And in that, we are printing n minus answer. And yeah, so left is initialized as 0, right is initialized as 0, and answer is 0, and small is minus 1. Now we're running a loop from 0 to n. Now we'll initially check if our small is minus 1 or not. So do we already have a candidate which is less than x or not? Now if we already have one, if we do not have one, then we'll see if my a of I is less than or equal to x. So if it is, we have got the candidate. Otherwise, we'll increase left because this left juice could be potentially used to fill up juice in the future, right? Otherwise, we'll say that, okay, we'll increase our right by a of x. So we already have a candidate which is less than x, but we have not already got enough juice to give it to that small candidate. So we'll increase our right by a of x. Now, if our small is minus 1, then we'll just continue. Otherwise, we'll see that can we fill up x units of juice inside a small candidate? If we can, then we'll increase our answer by 1 because we have got a juice which will stay till the end. We've got a glass which will stay till the end. And now we'll change the values of left and we'll reset right at 0. We'll reset our small indexes minus 1 because we still need to find it. And yeah, that is pretty much the whole solution. The time complexity is n squared. And I hope you like the solution. Thanks. Bye bye.